Hello, in this tutorial I will demonstrate how you can use Blender to extend the capabilities of Revit in regards to 3D visualization, architectural visualization, and basically making a 3D model that you've created in Revit look pretty. So let's get started. I'm going to do a quick explanation of some key features of Revit and Blender, and go over some of the nomenclature that's regularly used in 3D modeling and design. But of course this can all be skipped ahead and you can get to other parts. So Revit, what is it and what is it used for? Revit is a parametric architectural modeling software. It's now becoming a standard for 3D modeling in architecture. This Revit utilizes building infrastructure management, whereas in the past you would use AutoCAD. You'd have an architect create the floor plans in AutoCAD, and then you'd have structural engineers work on creating the structural elements of the building, and it was all very partitioned and very separate, and it was very difficult to manage a large scale project such as a building, because there were so many different people who were working on the project and they all had to have their own plans. So with Revit, it allows you to model and do many of the things that would otherwise have been separate in the past. So you can model a building, get all the floor plans, rendering of the building, and the structural aspects of the building, and many other things. So it's very useful for designing everything at once and then being able to pick apart those different aspects of the building. Alright, why would we want to use Blender? Well, Blender is, first of all, open source, so it's free. It's always going to be free. Blender is in many ways superior, I would say, in some aspects, to the 3D rendering capabilities that are built into Revit. Of course, there are third-party add-ons and applications that you can use with Revit for rendering and 3D visualization. However, being able to use Blender in your workflow will give you, I think, a lot more flexibility and a lot more opportunity to create something that is very beautiful and very stunning, while using something that is also very lightweight and, of course, free. Okay, so with architectural visualization, why would we want to show a building and render it out? Well, we want to get a better sense of the building. It's one thing to see it, modeled and in Revit, but we'd want to see what it would look like once it's actually built. We want to get a better interpretation of the final product. We could play around with certain things like lighting. What would a room look like during the day versus what would it look like at night? We can change the interior lighting settings and the exterior lighting. How is this building going to look? What is this room going to look like in the south side of the building with all the light coming in through? You also want to have something that looks good for a client, or if you're proposing a project that's going to be built. You want to have something that will convey the final product and how stunning it can look. Other uses, lighting, exposure. Again, what will a room or a certain part of the building look like during the day, at night, in the morning, in the afternoon? We want to see those aspects of a building. 3D elements put into a building. Let's say you have a plain room. Well, that's great. What would it look like once it's in use? Would there be shelving units? Where would a bed go? Would it look comfortable? How much space is actually in there once you have furnishings in there. So by doing all of that ahead of time, you can get a better sense of what the space will look like and how it will be utilized. So it's very useful for interior design. That's basically interior design, but you're doing it virtually. And of course, you can see, you can model things as you go. You can change aspects, you can change lighting. So by doing visualization of an architectural project, you really get a sense of what the place will look like, and things you'd want to change, and various aspects that later down the line may be more difficult to do if the project were actually a real proposed project. Now getting into some 3D related topics, object material. In 3D, you have an object material that defines the color information, shader information, and can give you UV mapping coordinates. Color information is basically, what is the color of an object? White, black, anything. Shader information, is it shiny? Is it a matte finish? The object could be, a glass material, anything. That's the shader information. That is what we define as what kind of material it is in, let's say, real life. UV mapping coordinates. When you apply an image to an object, you have to apply a 2D image to a 3D object. So you have to basically take this 3D object and flatten it out. And that flattened 3D object will have an XY coordinate where the colors in a 2D plane will define the colors of the 3D object, since they are both related to each other via UV mapping and UV coordinates. So that's how you can get color, an image projected onto a 3D object. Going to a bit further detail with texture. Again, you have color information that can be defined by a picture. You have shader information that can partially be defined by a picture as well. You have varying values from black to white. In the program, white could be defined as 100% or black could be defined as 100%. So within that, you can have a texture that conveys that information of varying values across a surface. Normal mapping, it's also known as bump map, can define how the texture of how a surface appears at different angles. Here with this brick wall, the normal is the faces that are pointing out in the Z direction towards you if you were looking directly at it. The Z axis, actually, to define a brick surface or a rough sidewalk or a muddy room, anything. Okay, on to the working with Blender. Okay, so let's say you download Blender, you would like to first import your project from Revit. You will need to export your project from Revit as an IFC file. And once that is done, you have to install a small add-on in Blender that will allow you to import that IFC file into Blender. So if you go to ifcopenshell.org, you can download the add-on that will enable this feature. I'm not going to go into how to do it. The instructions are on the website. You just need to download the appropriate version for the version of Blender you are using. Currently, the latest version of Blender is... The version I'm using is currently 2.78. Yes. So as of now, the latest version of Blender is 2.78. And that is a version you'll have to download if you are working with that version on Windows, Linux, OS X. Okay, so now you'll need to you can go to user preferences and go to add-ons, search IFC. Oops. So you'll need to have the correct version, otherwise it won't work. Okay, so go to File, Import, Industry Foundation Classes, IFC, and open. Okay, so once you have your file imported, you can go ahead and rotate it around to see that nothing's missing. Now, I found that when I imported my file, Blender appeared to freeze. This seems like it is just the regular behavior of the program. So if you have a larger, more complex building that you're trying to import, Blender may freeze for a few minutes, but just give it time and the program will finally unfreeze and you'll see your model in 3D space. Okay, so let's go ahead, and the first thing we want to do is scale the model down a little bit. So hit Control A, select all, Z to see our floor, to get wireframe view, S, and what I like to do is press and hold Control. That way I can snap the scaling by increments. But we also want to scale it to the floor here. So what we'll do is change from median point to 3D cursor. So wherever our 3D cursor is, our object will scale down to that point. So we want to do Shift S, cursor to center of our grid here, and we can now scale it down to that point. Now you don't really need to scale down, however, personally I prefer to be working within this grid here. And that way I have a point of reference. Okay. Now, as you can see, our building has color, which is good. We'll see if we go to materials. We can see that the names of the various objects, the material names, were saved and their colors were also saved. However, other aspects of the material were not. So if let's say we click on a window here, well, we do have some aspects that were saved, but they're not going to serve us very well if we were to just render this as it is. So you can see that this object has a transparent bluish material. That'll serve as a window material. However, we may want to change these to create more realistic materials. Also, within Blender you have the standard Blender render engine, but as of previous few versions, you also have cycles in Blender, which allows for photorealistic rendering using a physics-based renderer. I believe I'm getting that term wrong, so correct me please if I am saying the wrong thing. Okay, so now you have your building. Great. What would be the easiest way to see this building look like it's sitting outside somewhere and you want to take a somewhat realistic picture, let's say, of the building? Well, easiest way you can get started with getting a somewhat realistic render of your building is by using an HDR map. An HDR image is a series of photos that are stitched together and allow 360 view of a texture. Now this texture, when used as a light source, will project light from a external sphere around your building, which, if you think about it, when we look around, if we're outside and we look around, all the light from around us is projecting on whatever we see. So this way we can get realistic lighting without having to create our own light sources within the program. So we'll go to World, use Nodes, Background, and we'll go to Environment, Texture, go to get our HDR image, and you can use any HDR you'd like. The one that I'm using I found on the web. It was free. You can find many HDR environment lights that are decent quality for free around the internet, and they'll serve you quite well if you need a simple lighting setup. Okay, so now we have our surrounding light source. Now we also need a camera in 3D space to give us a reference for where we're actually rendering our building from. So go to Camera, go into Perspective View, and grab our camera here, maybe lower it down to the height of the building. There. And now we can also preview what we'll see in our render. And here's our building. So now, let's say we wanted to get more directional light. We can go ahead and add a sun to our scene, change the direction of the lighting so that it's a bit angled, lower the intensity of our environment lighting, say about 6. Let's see. Let's grab that. The thing about 3D rendering is that in reality, we usually don't have lines that are perfectly straight, edges that are perfectly sharp. So the trick to getting a realistic image is trying to make things as imperfect as possible. And that's done through adding textures to the various surfaces, which will allow the person who sees the image to assume that these different objects, these different surfaces, are representing different types of materials. So as things are now, this looks like a simple model, and it's very easy to distinguish it as a 3D model. So there's plenty of tutorials out there, plenty of resources to get started, changing materials, adding textures, and learning how to create a beautiful and believable render that will simulate the qualities that you would see in a finished building or a finished interior room, or whatever it is you would like to show. So I hope this tutorial was somewhat helpful. I'm sure I'll be changing a lot in future revisions, future videos, and if there's enough interest, I can go ahead and carry on further with details regarding creating a more realistic render of a building. Let's just render this out. So thank you for watching, and hope you found this useful.